Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on LPWAN, which actually stands for Low Power Wide Area Network. For this video, I'm going to concentrate on the 4Cs, the 4Cs of LPWAN. The first one will be the cost. The second one will be current, which is related to the power. The third one will be the coverage. And last but not least, the capacity of LPWAN. So this will be the objective of this video. This will be the part 4 series discussion on LPWAN. So if you're keen to know more about LPWAN, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on LPWAN. I have decided to regroup the discussion on LPWAN so as to achieve a better learning outcome. This is my email. If you have any question regards on this discussion, please drop me an email. Before I continue, I'd like to urge you guys to support this channel by pressing the like and also the subscribe button. Please also turn on your notification bell in order to receive more information from this channel. Guys, once again, really thanks so much for your strong support for these past 2 years. Thank you so much. Let's understand the emerge of LPWAN, why we need to have new type of wireless connectivity such as LPWAN. 10 years ago, the market for connected device was considered to be very small, and mostly they are dominated by personal area network, PAN, technologies such as Bluetooth and ZigBee, and also local area network, which known as LAN, technologies like Wi-Fi. About 10 years ago, in the year 2010, we have quite a limited numbers of connect device. I mean, there is definitely a lot of connect device in terms of cellular, but in terms of IoT application, they are considered very small, and they are mainly dominated by either the personal area network, which is the Bluetooth and ZigBee, and also the local area network such as Wi-Fi. However, due to the sudden hype around IoT, many analysts at the times predict most of this volume will go to PAN or LAN technology, but not many to the traditional cellular, because cellular you have issue of power and also the cost. Again, the expert anticipate that there will be more and more on connected device, and very soon both PAN and LAN will not be able to suit the need of IoT application. This sparked the birth of LPWAN. So basically, this is roughly the outcome why we have this LPWAN. When LPWAN technology just started, they do not really consider as a viable wireless connectivity for IoT applications because they can carry too little data. Because the amount of data they can carry is so little that the expert think that at that moment, LPWAN may not be a suitable connectivity for IoT application. However, later on, experts realized that IoT application do not really need to carry large amount of data, because IoT typically just send a very small amount of data. This change the view of the expert. Now, expert think that LPWAN maybe is the solution for IoT application. Coverage is a key requirement for many IoT application. But PAN, which is personal area network, and local area network LAN technologies, they can only provide very little coverage. You can imagine how long will be the connectivity in terms of range for Bluetooth. Let's say typically it's about 30 meter. How about ZigBee? ZigBee, a good ZigBee, maybe about 100 meter. But they are actually considered a very short range. And also for Wi-Fi, the range is also maybe about 50 meter. So basically all this technology, Bluetooth, ZigBee, and Wi-Fi, they can only provide very little coverage. They can cover properly at the most 100 meter. Even traditional cellular, which has a superior coverage, still has dead zone deep inside buildings or in a very remote location. I guess you know that even how well received your mobile phone, okay, definitely there will be still some zone that you cannot receive any cellular service at all. Okay, this become a real issue. Okay, the core IoT application need is the 4C, the cost, the current, the coverage, and also the capacity. Okay, so this is a diagram. Okay, so basically the cost, okay, we focus on the device cost and also the service, okay, which means that how much we need to pay for the particular connectivity. Next will be on the current. Okay, the current basically relate to the battery life. Okay, so let's take a look how this actually change the requirement of LPWAN. Next will be on coverage. Okay, LPWAN is known for long coverage. Again, okay, because of this long coverage, LPWAN become a feasible solution for all these IoT application. Next will be on capacity. Okay, you can imagine that more and more devices are required to connect to the internet. Hence, there's a mean that we need to increase the capacity so as to support this feature. LPWAN, low power wide area network technologies are developed for, firstly, for low data transfer. When we have low data transfer, we don't need such a bandwidth. And when we don't need such a bandwidth, we can actually enhance the distance. Next will be low current consumption. Okay, again, as I mentioned earlier on, okay, for LPWAN, most of the time they are actually sleeping. Okay, when they actually sleep, they don't consume lots of power. Next will be on low cost. Okay, I will explain how to achieve low cost for LPWAN device. And then last but not least, on the enhanced coverage. Okay, basically all these policies are mainly focused on IoT applications. Let's come to the cost. Okay, how can we reduce the cost of chipset and module? Okay, I think the key idea to reduce the cost is simply to achieve by reducing the complexity. Okay, the simpler the chipset, the simpler the module, you actually reduce the cost. Okay, so the key idea again is to reduce the complexity in modem so as to integrate only the function that are required by the IoT application. Okay, which means that, for example, you don't need to have so much processing power. You just need to have little processing power to process the IoT message. Okay, so this indirectly also reduce the cost. Also imagine that for some application for IoT, instead of two antenna, I just need one antenna. Again, this will also reduce the cost. Okay, LPWAN technologies meet efficient and low data transfer, which bring down cost of monthly or yearly network service provider subscription. Okay, in terms of LPWAN, typically in terms of monthly, okay, you are only expected to pay about $1 a connection. Okay, anything more than $1 a connection, I feel that is actually quite high. Next, let's move on to the current consumption. Okay, LPWAN technologies are developed for low data transfer and low current consumption. Okay, mainly focused for IoT application. IoT device, they actually operate in a challenging environments. Okay, in a remote location where changing battery is costly. Okay, imagine besides changing battery, imagine we are going to deploy billions of devices and imagine to change billions battery. Okay, this is definitely very tedious. So therefore, changing battery may be a key issue. We want to reduce the frequency of changing of battery as much as possible. Hence, low power consumption is among the most important requirement. Next will be in terms of coverage. Okay, IoT will deploy in extreme challenging environment. Okay, we potentially will deploy this device, okay, in a remote area. Okay, whether is it indoor or outdoor, or maybe sometime we also deploy this IoT device in a moving vehicle. The extended range actually enable the IoT device to communicate with the network in this challenging environment. Okay, because of the long range. Okay, so therefore we still can locate the device, which means that the gateway may be still able to locate the device. Therefore, there is always a lot of motivation to improve the coverage or increase the range. Capacity. Millions of devices will access to the network. Hence, increased network capacity is an important requirement. Again, we deploy all the device. All the device typically require to access to the internet. Hence, we need to increase the capacity. The skill to support a massive number of machine-type communication mobile station is achieved by reducing the signaling process. Okay, can you still imagine this, all the Bluetooth pairing, etc.? So basically, there is not of signaling process. Basically, for LPWAN, okay, we achieve higher capacity simply by reducing the signaling process. Okay, hence, these are all the 4 C's of LPWAN, okay, which is the cost, the current, the coverage, and also the capacity. Why we need to use LPWAN? Okay, the application and deployment scenario are nearly infinite. Okay, imagine that we can deploy LPWAN for many IoT. Okay, in fact, okay, this is what it means that it is almost like a nearly infinite application. Okay, but the bottom line is that LPWAN technologies unlock the potential of IoT and open new IoT use case by providing the 4 C's, which other wireless technology can't provide. Okay, so this is a key point. LPWAN unlock all the potential for IoT application because all the other wireless can't seem to support this kind of application. There are definitely applications where PAN or LAN technologies are still the clear choice. Okay, having said so much, okay, definitely there will be some application that require the PAN or LAN. Traditional cellular also has its unique set of advantage, okay, that PAN or LAN and even LPWAN technologies cannot provide. Okay, for example, we need to have a lot of mobility. Okay, this typically can only support by cellular. And also, let's say we need to have a high data rate. Okay, this again can only be supported by cellular. And without the complexity and the need to pair device to an access point. Okay, so basically all these you still need to rely on the cellular. As for the PAN, okay, basically for example, if it's a smart home, okay, which the gateway can be just nearby, you can consider to use this personal area network to send the data. Currently, when it comes to IoT, many applications are happy with low data rate and only need to transmit very small amount of data. Thus, efficiency is not as big a concern compared to consumer application like smartphone, which send gigabytes of data. So over here, you can see that typically, okay, we always want to emphasize that for IoT application, they don't have a lot of data. Just a very small amount of data is good enough. Basically, when we actually have a small amount of data, we can actually reduce the amount of bandwidth, which indirectly also increase the range. Okay, maybe in the next few series discussion, I will explain how bandwidth reduce can actually increase the range. With this, I'd like to end my discussion. Please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now.